Hi, I'm Darren and welcome to Level Up EE Lab. Well, since the last episode, I have made tremendous progress on my Heathkit DX-60 restoration project. Let's check it out. Alright, I've made great progress here on reassembling my Heathkit DX-60, and most of the work since the prior episode has been on the top side of the chassis. So let's take a quick look at some of the more interesting bits here, starting with the power transformer. I think this is the first time I'm showing it installed and in place, and obviously it looks really sharp. I painted it this matte black finish, and this looks very nice, very traditional against the gray chassis. And I did reinstall this filter cap. It's not electrically connected anymore, but keeping it in place definitely preserves the original look of the unit and prevents having a gaping hole here and having to cover it or do something else with it. I've also obviously installed the meter. Now that went very easy. I did end up having to mark and drill 3 new holes for the 3 bolts that are in the meter to fit through. They didn't match the Heathkit 4-bolt pattern, but that was, like I said, pretty easy to do. And then dimensionally, it's almost the same length and width and depth. It is a tiny bit taller, so I did have to shift it a little bit, but otherwise it fits right into place. I will have to make a little chart to keep handy when I'm using it because I decided I was not going to open it up and put a new scale in there, so I'll just have to keep a conversion chart handy whenever I'm using the rig, but no big deal. But also notice the 2 illumination lamps don't quite match in height, so for whatever reason I only had this one on the rig, and according to the assembly manual there's supposed to be one over here as well. Well, I rummaged through my parts bin and I found a socket, but it's a little different bracket, so it sits a little bit higher, but no big deal. I think I can live with that just fine. I would also comment, if you look at the meter, there's 2 back-to-back silicon diodes there. I used a couple of 1N4003s because that's what I happen to have handy. That's considered a good practice on these old analog meters to put back-to-back diodes across them. What they'll do, hopefully, is if there ever is a fault condition that puts overvoltage on the meter, they'll kick in and conduct and prevent or limit permanent damage to the meter. So it doesn't hurt to have them there. It might help if there is a problem, so I went ahead and installed them. I've also got the replacement for that 30K center tapped resistor, this double power resistor block installed. And if you remember, this is what the original looked like, and at least half of it, I think, was open circuit when I was checking it, so it was definitely not going to work. So that just dropped right in and looks nice. And then the other elements I want to show are inside of the final amplifier area. I only have the shield temporarily installed, so let me pull it off so we can get a closer look. All of the elements in here dropped right in, and if you remember, these 2 I got off of eBay. I really needed this, the tank loading coil, because my original was in terrible shape, but I just used the same loading cap as well. Everything hooked up just fine. The last thing I'd comment here before I get back to assembly is this parasitic choke. These are commonly used in old power vacuum tubes to suppress RF harmonics, and really all they are is just a carbon composition resistor with a couple or several turns of wire wrapped around them to add a little bit of inductance. Unfortunately, that center resistor tends to go bad. It's carbon comp and it heats a lot of heat, and it's a little tricky to check those. You can't just put an ohm meter on them and measure them, obviously, because that coil will short out the resistor. What you need to do is carefully desolder one end of the coil and then check it. And I'm glad I did, because mine measured between 120 to 130 ohms, so it definitely needs to be replaced. You can't drop in any old resistor there. It needs to be a non-inductive resistor, so another carbon comp would be fine, or a modern equivalent is a ceramic resistor. There's a series, it's the OX series made by Ohmite, that will work just fine here. And the 1 watt size fits nicely inside the coil. It has a little bit of clearance, but that's perfectly fine. You don't want to distort that coil and open it up to put it over a larger diameter resistor. So I'm all set to go here with the top of the chassis assembly. The next steps in the assembly manual, flip it back over to the bottom side. All right, I've completed a major milestone here. I've finished the final wiring section of the assembly. That's pages 28 through 31, I think it is. Yep, 28 through 31. And everything looks great. And this was a lot of fun to put together. This really felt like putting together a Heathkit for the first time. So let's talk about some of the things that I did here. Obviously, I've had to make some major modifications to the AC mains. I'll come back to that in a moment. What I do want to talk about right now are these two potentiometers. I skipped those in an earlier video, and I do want to touch on those briefly. So we've got R28 right here. That's 100K. That controls the audio gain. And then there's this big boy right here, R6. That's a 4-watt, 25K wire wound. It's kind of a unique wire wound design in there, as I'll show here in a moment, because I did have problems with both of these. They were very erratic and noisy electrically, but I did get lucky. They did respond well to my cleaning and fresh lubrication, and they now both seem to be working just fine. This one here would have been a little tricky and expensive to have to replace since it's 4 watts, but I think I'm good. They tended to turn out just fine after I cleaned them and lubricated them. A couple other things to talk about here, the band switch. This is a combination of an area that's very delicate, and then a wafer that's very delicate, and then these connections here that are very rigid and stiff. So putting this together is a bit tricky. The end down here with the driver plate coil is especially delicate, and I tried to be as careful as I could handling it. In fact, I think this one was actually cracked at some point because there's a couple blobs of JB Weld epoxy or some similar repair on there, and I was afraid I was going to bust it in half. So I'm hoping it's still good and it'll hold up as I go through the trials here and get it tuned and get it on the air. Obviously, I've also installed the push-to-talk module, this guy right here, and that dropped right in. And as I mentioned, I got this video or earlier video, the clearances around here are pretty good, but you can see there isn't that much space with this shaft. So I waited until I had all this assembled before I put it in place. And then ultimately, I used a couple of these, I hesitate to call them Velcro. They're kind of like a modern version of it maybe, but they're little separable pieces of adhesive. Got double-sided adhesive on both sides. That's what I got that stuck in there with. So it's a little flexible and I can pop it out again if I need to. I figured this stuff would be fine. I mean, after all, it's holding the toll transponder on my windshield, and knock on wood, it hasn't fallen off yet. Also, you can see I've got a tiny bit of that spiral loom here because what I ended up doing, rummaged through the junk box, and I found a couple of these 12-volt red incandescent panel lamps, and I figured, well, I got 12 volts on the board here, so I just ran a little connection back here to my push-to-talk module, and that's what's going to come on whenever the power supply is on. And then lastly, what I want to comment on before I get into the power supply is I did end up replacing that, here it is. That was the 2-watt 33K new old stock carbon comp I bought. That measured about 44K. Well, this is the modern replacement here. That is a 2-watt 33K metal film, and you can see quite a bit difference in package size, but I think it should work out fine. So next up, I got to talk about the power supply down in this area. Power supply. Let's take a close look now at the AC main side of what I did, and I've actually made a little schematic here we can take a look at as well. Now, of course, I've added this 3-prong cord, this guy right here, to bring it up to modern standards for safety. And of course, the ground connection is connected to the chassis. Normally, I would prefer to put a socket here and have a removable cord, but it just wasn't an option, wasn't enough space. So I've got a nice strain relief that I've put on here, as well as putting a standard fuse holder right next to it. And best practice, of course, is to put that fuse, of course, on the hot side, but have it be the very first thing that the connection sees before you get into anything else inside the rig. Capacitors for noise filtering. I've got 2.01 microfarad or 10 nanofarad if you prefer caps, one from hot to ground and one from neutral to ground. They are safety caps. They're X1, Y2 rated caps. I used 0.01 because that's just what I happen to have on hand. I looked at the DX-60B schematic, the rig that came a little later from the DX-60 that I have, and Heathkit actually used 0.005 there. So I've also seen as low as 0.001. I'm sure there's some rules of thumb or maybe some lore about what value you really need there, but I've added some filter capacitance for noise, so that's only going to help to help reduce any noise that the transmitter might be feeding back onto the AC line. Of course, after all that, we got the power switch, which again is up on the function switch at the front of the rig. And then this guy's a new added inrush current limiter, and that's the particular part number that I have here, CL-90A. And that suggestion comes from Wireless Girl. If you go over to her website, she's got a lengthy write-up on her work on the DX-60 over the years. And I read through that, and it makes a lot of sense here because I've taken out the switch for the high voltage circuit, the 600 volt circuit. And when you first turn this rig on and charge up these capacitors, there's going to be a fairly decent inrush current there. Well, this guy right here, this is the ICL mounted down here. At room temperature, it's about 120 ohms, and it's going to rapidly heat up, like, tenths of a second, couple seconds or so, whatever, and then drop to just a couple of ohms. So that helps cushion that surge that goes in when the power supply is first turned on. So I think that is wise. I think that was a good idea to put that in there. Switching back to the top of the chassis for a moment, there's a couple final mechanical elements to talk about here, one of which is the strain relief. We can see it now. And I've got several of these I collected over the years in my junk box from Hamfest, and these are really nice. If I have to use a power cord like I did here, I like to have a nice strain relief that prevents any forces that are on the cable either twisting or tugging from putting strain on the connections on the underneath of the chassis. So that's really nice. Unfortunately, and this will probably show up on camera, there's a couple of big scratches in the paint here. Not sure how that happened. I'm just guessing it happened when I was installing the strain relief. But as it turns out, this particular brand of hammer finished gray spray paint is pretty soft. I'm not sure what else to attribute it to. There's several areas on the chassis where the screws have chipped the paint just from twisting them when I tighten them down. I've never seen that happen before on my projects. And I did the exact same prep work I always do on all my painting projects. So I'm just blaming the paint. It's not that big of a deal. The chassis still looks really nice and certainly much better than it did when I started the project. And speaking of looking nice, I also painted the low pass filter shield box here. And this is the one that came with the tank coil that I got off of eBay. And you can kind of see the tank coil up at the top of the screen, barely, maybe right here, behind the amplifier shield. I was really suspicious that this one that came with the rig was not going to perform the way it should, per the stock configuration, mostly because of that replacement cap that's in there and then obvious signs of damage that had happened. Something got really hot in there and burned out or blew up. So as it turns out, I was right to be suspicious that this filter was a little off because I made an attempt to measure the S11 parameter on both of them. So that took a little cobbling up of a connection here because there is no coax that comes out of this. It's just a heavy gauge wire. So that's not exactly textbook quality, but I did the same setup on both and of course put a dummy load on both. So any connection error should be kind of the same for both of them. And of course, I also made a SPICE model of the Heathkit design. The schematic and the parts list have all of the inductor and capacitor values, so building the model is easy and straightforward. So here's how the three of them compare. The model in this plot is the dashed blue line. It has two nulls, and the responses are very sharp because the inductors are modeled with a very high Q. The filter I got off of eBay is shown in green. Now it tracks closely to the model, especially at low frequencies. Its null at just over 10 megahertz is not as sharp, and I think that's mostly because the Q factor of the coils are likely lower than in the model. But look at the orange plot. That's the one that came with my rig. Its response is considerably different. So changing that cap and maybe some tweaks to the coils that I can't see have definitely shifted the response. I'm at the point with the assembly process now where the next steps really get into checking it out with a multimeter and powering it up for the first time. And I'm going to have to save that for the next episode because that's quickly going to get into making sure it works and, of course, getting it tuned and aligned and getting it on the air. And there's one other mechanical item that I got to save for the next episode. I've got these 5 knobs that go on the controls along the bottom of the front panel, and all 5 of them are in really tough shape. They're cracked and they're just not usable, but I've got an idea for restoring these and being able to put them back on the rig and make them stronger than they were originally. So I hope you're enjoying this series and will stick with me for the next and what should be the final episode in the series on this Heathkit DX-60. So until next time, bye for now.